right, let's talk about absolute value equations and inequalities. Absolute value represents the distance from the origin on the real number line. So for example, the absolute value of 5 is 5 because that's the distance from the origin. And the absolute value of -5 is 5 because that's the distance. Remember, distance is always positive. And if you have the absolute value of an expression x minus a, that's the distance between x and a on the real number line. All right, solving absolute value equations. The first thing you want to do is isolate the absolute value. And then when you remove the absolute value symbol, you have to write two equations. Now that's only if the right-hand side is a positive number. If the right-hand side is 0, you're only going to get one equation because 0 cannot be positive or negative. Or if the right-hand side is a negative, and we'll talk about that in another example. But let's do a simple example first. So we'll solve for x. The absolute value of x minus 2 plus 3 is equal to 11. So we want to isolate the absolute value. So subtract 3 from both sides. And remember your definition of the absolute value. Whatever is inside of here is either equal to 8 or -8, because the absolute value of 8 is 8. The absolute value of -8 is 8. So we just write two equations. And we use the union symbol. If we use the intersection, that means both of these would have to be true at the same time. But this way we have x can be equal to -6, or x can be equal to 10. All right, let's try another. All right, solve for x. The absolute value of the quantity x plus 4 minus 5 is equal to 7. This would be a good time to hit the pause button and try this one on your own. All right, let's check your answer. So first you want to isolate the absolute value, so we add 5 to both sides. So the absolute value of x plus 4 is equal to 12. And remember, whatever is inside of there is either equal to positive 12, because the absolute value of positive 12 is 12, or whatever is inside of there is equal to negative 12, because the absolute value of negative 12 is 12. So let's write the two equations. So if x plus 4 is -12, we subtract 4 from both sides. If x plus 4 is equal to 12, subtract 4 from both sides. And that's it. Let's talk about what happens if the right-hand side is a negative number. Let's say you isolated your absolute value, and you have that your absolute value is equal to a negative number. Well, that's not possible. The absolute value is always going to be positive. So you would just say no solution. All right, what do you do if the right-hand side is 0? So remember we talked about this, 0 is neither positive or negative. So you're only going to get one equation. And one solution. absolute value inequalities, there's basically two different types of absolute value inequalities. We have the type where the absolute value is less than a positive number, or the absolute value is greater than a positive number. I call these type 1 and type 2. I made up those names, but it helps me remember which one is which. Because when you have a type 1, when the absolute value is smaller, you rewrite it as a compound inequality, and it's all one inequality, where x is between 3 and -3. When you have a type 2 inequality, you get a compound inequality that has to be written in two parts. So the first part looks just like this. Now notice this is a greater than or equal to, so we'll use greater than or equal to. And the other one is the opposite. So x is less than or equal to -5. We have to use the union symbol in between those. And then let's draw the graph. So just like before, you're going to graph your boundary values. And then you have 3 regions to check. And most of y'all can probably just guess which region we shade from here. But if you're not certain, use the original statement to test your 3 regions, and you'll never go wrong. So if you mix up your type 1 and type 2, and you can't remember whether it's all one compound inequality or 2 inequalities, use your absolute value properties to get the boundary values. I'll show you how to do that in a minute. And then test using the original inequality. So let's just try some numbers here. We'll put them in the original inequality. So is the absolute value of 5 less than 3? That's a false statement. Is the absolute value of 0 less than 3? That's a true statement. Is the absolute value of 8 less than 3? That's a false statement. So we shade this part in the middle. It's a strict inequality, so you can either use open circle or the curly bracket. And in interval notation, x is an element of the set from -3 to 3, not including -3 or 3. All right, for this one, we put our boundary values. We have 3 regions to test, and we'll use the original absolute value inequality statement. And remember, that protects you if you made a mistake going from here to here. If you always use your original statement, it's a little bit more work, but you'll always get the correct answer that way. So we'll test our 3 regions. Is the absolute value of 8 greater than 5? That's true. Is the absolute value of 0 greater than or equal to 5? That's false. Is the absolute value 10 greater than or equal to 5? That's true. So this is my solution set. And because it's a greater than or equal to, we include the -5 and 5 in the solution set. And whenever you have a disjointed solution set, you have to use two parts with a union. If you try to write it all as one statement, that won't be correct. So you go from negative infinity to negative 5, 5 to infinity. All right, let's do a more complicated one, and I'll show you a fail-safe way to do it without having to remember these two things. All right, this is a nice little problem. You could look at it and try to decide if it's a type 1 or type 2 and solve it that way. So I would hit pause and try this one on your own. All right, and another method is to just solve for the boundary values. Solve for the boundary values using equality, and then test your regions using the original statement. What does that look like? So replace this inequality with an equality, and that's just a temporary helper. Solve this absolute value equation, and remember that you get two equations. Solve the two equations. And these are my boundary values. So let me draw the graph of those. Now that I have my two boundary values, I can see that I have three regions to test. So just pick any number in those three regions. And when you test them, use the original statement. So I just picked any number in that region and plugged it into the original statement. So -8 minus 3 is -11. The absolute value of -11 is not less than or equal to 7, so this is false. And here I put 0, 0 minus 3. The absolute value of 0 minus 3 is the absolute value of -3, which is 3. And that is, in fact, less than or equal to 7. So this is a true statement. So I'm going to include this region in my solution set. And we put in 15. 15 minus 3 is 12. The absolute value of 12 is not less than or equal to 7. So that is a false statement. And the original statement had less than or equal to. So that means we include the boundary values in the solution set. We write the solution set as X is the element of the set from, and always write it from left to right. So the -4 goes first, and then the 10, and square bracket. And that's it.